My name is Ruby Patterson. I am a PhD candidate from the University of Houston, and like Erica mentioned, today I'm going to be talking about determining the ages of rocks accessible within the Artemis exploration zone. Next, please. In a workshop like this, it's really important to keep in mind all of the science priorities and potential that each exploration region bears at addressing these priorities. And so the scientific priorities that are most relevant to my talk today are interpreting the impact history of the Earth-Moon system to start off with. So chronologic investigations are going to enable the untangling of the complex history of the evolution of a differentiated planetary body. That's pretty major. This will also allow us to learn more about the structure and composition of the lunar interior. We're also going to gain tremendous insight into key planetary processes just by taking inventory of the diversity of lunar crustal rocks with respect to variety, age, spatial distribution, and their origin. Here is a widely used geologic base map. There were several others that were put forth today, but here's one that I'll use for my talk. It was recently updated based on new model age data from Tai et al. And Deutsch et al. And the thick black boxes that we all know are the Artemis landing regions, 10 of the 13 that just so happen to fit within the boundaries of this map. And this map is a really good first estimation of what the ages and potential types of return samples from these regions might be. These locations will enable us to sample massif, terra, and ejected materials from primary and secondary craters. And so the lithologic compositions, or the average lithologic compositions within each of these regions, was examined using remote sensing with the help of Miriam Lemelin, who some of you may know. Next slide, please. On this slide are two composition maps of the Artemis exploration region. These data are from the Kaguya spectral profiler. The left figure is plagioclase abundance from 50 to 100 weight percent per pixel, and the right figure is iron oxide abundance from 0 to 15 weight percent per pixel. The red squares are, of course, our exploration regions. The grayed areas are PSRs, and the black spots are places where no data exists at all. And the takeaway message from these figures is that we're definitely going to be exploring a feldspathic impact terrain. And these data were used to calculate the average lithological composition at each of these regions. Next slide, please. So the data from the spectral profiler investigation returned results that plotted the average lithological composition within the blue shaded area of this diagram. So roughly the landing regions are roughly anorthositic. And so we decided to shade in this whole upper part of the triangle because the error bars were very large, because there's a very coarse spatial resolution with Kaguya data, as many of you may know already. But given the highly impacted nature of these landing zones, brecciaclasts, which are for sure going to be below the coarse spatial resolution of the spectral profiler, these brecciaclasts could be of any lithological composition on this ternary, which is very, very exciting. Next slide, please. So for ease of communication, I've lumped lithologies into the following groupings. The red portion is representative of anorthositic lithologies. Mafic lithologies are this orange part in the middle, and ultramafic lithologies are the yellow portion of the diagram. And I also mentioned impact melts and breccias in this talk, but they are not classified using this diagram. Next slide, please. So here are some of the chronologic opportunities that we can expect to have from return samples. And previous work has found that chronologic investigations can aid in determining crystallization ages, model ages, true impact ages, and even like timing of melt extraction. It's very, very powerful. And so starting at the top, anorthositic lithologies can be very difficult to date because they have a very high plagioclase content, but they can potentially have those chronometers applied to them. The length of the arrow is indicative of what chronometers can be applied to those lithologies. Mafic lithologies will help define magmatic periods and chemical characteristics of mantle components. And they have a lot more chronologic opportunities because of the higher proportions of pyroxene and olivine. And most notably, mafic lithologies are going to be very powerful because they have the chance of us finding uranium-rich trace phases within them, such as apatite or zircon. And it's still unclear to us if uranium-rich trace phases are going to exist within the return samples we bring back, but if they do, they are going to be the most precise method of dating available to us. Ultramafic lithologies are mantle rocks, and so they mostly exist at depth and are more constrained with respect to the chronologic opportunities that they have. If we found ultramafic clasts, it would be a really big deal because we only have a few small clasts in our Apollo record to be representative of the lunar mantle. And then finally, the green arrow is representative of impact melts and breccias, which are probably the most valuable types of return samples because they're going to offer the most variety of lithologies within a single sample. A single breccia sample could potentially use all or just a few of these chronometers, and it's going to be completely lithic class specific. They also have the bonus option of dating the impact itself through argon-argon techniques, but sometimes uranium-lead, and the now emergent in situ rubidium-strontium techniques. Next slide, please. Okay, so here's the same base map from the beginning of my talk with the 10 of the 13 landing regions outlined. Next, please. And so I'm going to walk through a few that I've highlighted that were the subject of a review paper that I'm currently writing right now. Next, please. Okay, so the first region I would like to highlight is the Gerlach Rim. This correlates to Site 011 from Mazarico et al. And I know we're moving away from, certain types of nomenclature, but sometimes it helps me to remember in older literature where what area we're looking at. So I've included it here. But the Gerlach Rim is expected to have surface units spanning in age from pre-Nectarian Terra all the way through Orientale Basin's secondary materials. Next, please. The next candidate region I'll highlight is Mons Mouton, the site formerly known as Leibniz Beta Plateau. Of the 4 regions that I highlight in this talk, this one is expected to host the least variation with respect to age, but these rocks are going to be very, very old. We expect them to be very old in this region and predominantly pre-Nectarian in age. Next, please. The third candidate region I'll highlight is Connecting Ridge. This region will potentially have ejecta materials from several Nectarian age craters, one of which is still unnamed. This candidate region also holds the potential to contain return sample ages ranging from pre-Nectarian, like Henson crater, all the way to Imbrian age, which is Shackleton crater. Next, please. The fourth and final candidate region I'll highlight is Peak near Shackleton. Samples collected here may be comprised of distal impact ejecta from Shackleton, Nectarian-aged Slater, and also the unnamed crater, materials from Slater and that unnamed crater, and also pre-Nectarian-aged massif material that is believed to form that peak outside of Shackleton. Next, please. So you may have noticed that each of the highlighted candidate regions have the potential to contain SPA impact material from these tables, but also the last 2 talks by Dan and Cameron mention this exact same thing. Sampling SPA material would be really significant because it would enable us to date the age of the SPA impact itself, which produced the oldest impact basin. But if SPA were able to be dated using absolute chronology, it would anchor the entire timescale of the moon, in addition to all the other things that Cameron mentioned in his talk. Next, please. There have been many analytical advancements since the 1970s, and for any lithology that we find, we have the tools to date it. Also, modern techniques really don't require the same large volume of sample as was required during the Apollo era. So in conclusion, there is no silver bullet method for all sample types. It's really going to take a combined approach between lithologies, chronology systems, and instrumentation to understand everything that we can from these exciting new return samples from the lunar South Pole region. Thank you.
All right, thanks, Ruby. We do have a couple more minutes before we're going to move on, and I think there was a question put in the chat for you. So what is the probability that any given breccia or whole rock found during EVA operations on the surface will contain unmodified mantle or lower mantle materials? And would this affect the choice of landing sites? Do you have thoughts about that?
Oh, I think if we do find mantle materials, they will definitely be modified just due to the intense shock pressure that would have to be imparted onto the moon in order to eject mantle materials out. And so I'll email you, Don, because we're buddies at Johnson Space Center. So I'll email you and we can talk about this later. But as far as unmodified, I don't foresee that. But anyone, please feel free to chime in on.
I have a sort of related question that when you were talking about the variation in the 4 sites, there were some sites, which one was it? Mons Mouton, that has less variation, but older rocks probably. So would you, if you could pick a landing site, or do you think that there is more to be gained from going to a site that maybe has a little bit less variation, but older ages versus one of the other sites that has a lot more diversity, but maybe you're getting more material contributed from elsewhere?
It all depends on what goal, what your number one science priority is. And of course, we want to answer as much as we can at all the sites that we go to. But if we really, really want to focus on establishing an absolute precise chronology of the moon, Mons Mouton would be a really good place to do that. And as Cameron mentioned, there's a lot of SPA materials that are there. And I would probably like to go there first. But again, this workshop is not about my opinion, but that is my opinion.
Okay, thanks very much.